Hello everyone, welcome once again to Nated Engineering. We are looking at an exercise today and we're still doing Forces Engineering Science and 3. We're looking at a question from the question paper that was written on the 30th of March 2017. It's question number 3 and we are going to start from 3.1. 3.1 says explain the term vector quantity. We know a vector quantity is a quantity which possesses magnitude and direction, like force, speed, etc. And then we move to the next one, which is 2.3. It's 3.2 rather. They say complete the following sentence by filling in the missing word or words. Write only the word or words next to the question number 3.2.1, 3.2.2 in the answer book. The statement they are saying a direct force is a force which acts 3.2.1 and onto an object. So 3.2.1 is directly and 3.2.2 is perpendicular, and the sentence when completed will say a direct force is a force which acts directly and perpendicular onto an object. And then we move to the next question, which is 3.3. They say a system in figure 1 below is in a state of equilibrium. Determine analytically the magnitude of the unknown forces. It's supposed to be P and T there. Never mind the G. It's P and T. This is the information that we are given. We are given this diagram and they're asking us to calculate P and T. So we are told that the forces or the system in figure 1 below is in a state of equilibrium, meaning the sum of the forces to the left are equal to the sum of the forces to the right. The sum of the forces going up are equal to the sum of the forces going down. Therefore, we are going to say, since we know that the sum of the horizontal component equals 0, we can then say 500 is going to the left, to the right rather. 500 is in that direction. What will be the force that is in that direction? It will be the component of P, which is P cos. We have to use the angle which it formed with the horizontal. This will be 45. 180 minus the 180 minus 135 is 45. It will be 45. And the value of P will be equal to 500 divided by cos 45. And this will give us the value of P as 707.107 newtons. That is the value of P. We still need to find the value of T. So let's move this up and calculate for the value of T. Now we are going to use, we will consider the vertical component, the sum of the vertical components. T is going up. Do we have another object, another force that is going up? No. It will be equals to the component of P, which is going down, will be P sine. It's the vertical component, therefore it's sine 45. We're going to say here we put the value of P 0.0, it's 107 sine 45. and that will be equals to 500 newtons. And that is how we were going to do the first question. We go to, this is 3.3, not 3.2. 3.2 is this one. So we go to the last question. They say it's 3.4. Analytically determine the magnitude and nature of the forces in the member AD and DC of the roof truss in figure 3 below. So we are given something like this. It's 3.4. We are given a diagram like this. We are only interested in this part CDA, and the force here is 2 kilonewtons. So we are interested in this part, the angle is 30. We are asked to calculate for the nature and the magnitude of the force that will be acting on these two members. So we're going to start by giving this member a direction. Start by saying the sum of the forces going up are equals to the sum of the forces going down. We say 2 kilonewtons, it's equals to the force that will be going down will be the component of CD. CD, the force which will be going down is sine, which is the vertical component, sine of 30. We are looking for CT, therefore we are going to say CT is equals to two divided by 30, sine 30. Which will give us an answer of 4 kilonewton. The answer is positive. It tells us that we are using the correct direction, therefore we're going to mirror it, giving us what? A strap. And then from there we are going to use the horizontal force, the horizontal forces. We're saying the sum of the forces going to the right are equals to the sum of the forces going to the left. And we're going to have the component of this will be going in that direction. So let's say this one is going in that direction. The component of CT will be cos 30. It's equals to 80. Is equals to CT, which is 4 times cos 30. And this will give us our AD as 3.464. It's positive, this answer, therefore our error is correct. We mirror it, giving us a tie. And that is how we were going to solve this question. And that's the end of our lesson. I will see you on the next one.